Good morning, myself Yasodha. I am working as assistant professor in SNS College of Engineering. Today we will discuss about Stokes theorem. Introduction to Stokes theorem. The surface integration of the curl of a function over the surface bounded by a closed surface will be equal to the line integral of the particular vector function around it. Stokes theorem gives a relation between line integrals and surface integrals. Understanding the curl of a vector field. The curl of a vector field is a vector field. The curl of a vector field at point P measures the tendency of particles at P to rotate about the axis that points in the direction of the curl at A. So, the curl of a vector field measures the rotation of the field at given point. So, we are using fluid motion, electromagnetism and more physics. Definition of closed curve. A closed curve has no endpoints and encloses an area. A curve in which the starting and ending point is the same, enclosing an area. Uniqueness. Every point on the curve has a defined tangent line. Statement of Stokes theorem. Surface integral. The surface integral of the curl of a function over the surface bounded by a closed surface will be equal to the line integral of the particular vector function around it. Stokes theorem gives a relation between line integrals and surface integrals. Understanding the flux of a vector field. Flux is the amount of something passing through a surface. The total flux depends on strength of the field, the size of the surface it passes through and their orientation. So flux measures the flow of vector field through a surface or a curve. Next, deriving the formula for Stokes theorem. Vector calculus. Integration over a surface and around its boundary leads to the theorem. Curl and divergence. Relates the curl and divergence of vector fields to surface and line integrals. Examples of applying Stokes theorem. In fluid dynamics, we are using Stokes theorem. Used to analyze circulation of a fluid around a closed path. In electromagnetic circuits, we are using the Stokes theorem. It calculates magnetic field circulation around closed paths in circuits. Relationship between Stokes theorem and Green's theorem. Green's theorem can be seen as completely analogous to the fundamental theorem. Stokes theorem is a higher dimensional analog of Green's theorem. Generalization. Both theorems relate line integrals to double integrals over a plane or surface. Applications of Stokes theorem in physics and engineering. In fluid dynamics, we are using Stokes theorem. We are applying the Stokes theorem. And aerodynamics, electricity and magnetism, electromagnetic induction. Thank you.